Since my last video, I've done a lot of refactoring. I'm going to go through some of the refactoring that I have done, but I'm mostly going to focus on procedural map generation using the Godot tile map and XX hash. So let's get started with that. Okay, so let's get started. Let's do our procgen first. So we're going to get our library, add a new module called procgen, which doesn't exist, so that'll create an error. And we're going to do a new file, procgen rs, there we go. Okay, so now we're going to create two functions. One which will pack two x and y coordinates into one unsigned 64-bit integer, and that's going to be our seed. And another one which will take a slice of something and a seed and return one of the options in that slice. Right? This is how we're going to select our tile type when we do our tile map, our random tile maps. Okay, so the first thing we need to a hashing library. Text hash, and then we need to use that. We need to use hasher and u32. And we can use that one, which is just an alias of 2x-64. Okay, so the first thing we'll do is we'll create a function to pack our coordinates, pack chords. Now we're going to call it pack x i32, y i32, and return a 64-bit unsigned integer. And we are also going to do a function here, pack chords, that takes a vector 2 and return an unsigned, and that means this doesn't have to be public. And then we need to add gd native. Vector 2, there we go. Okay, so now we can call this function. We can call pack with our chords x as i32. Dear me. Chords y as i32. There we go. Okay, so now we just need to do the actual packing. So x is i64. X becomes y. And then we can now pack these two together. I think that's right. No, lots of errors there. U64 because the return. Oh, right, sorry. Okay, dear me. There we go. Okay, so the next thing we're going to do now is we're going to create the random choice. Let's generic over t and takes a slice of t. Take a slice of t. And a seed, u64, and return a reference to t. Okay, and how do we do this then? Well, first we need a hasher, and we have our xx hash with seed, and there's our seed, and then we can get a hash from that, and then we can have our index into our slice is going to be hash as u size, because we need a u size, and let's do modulus slice length, and then then we'll simply return slice index. That seems, maybe we should say that's a function as well. Okay, expected. Well, then we'll do that then. Okay, so now we can get a random choice, so we can use this to pass in a list of tile IDs from our tile map, and we can put our coordinates together use that as a seed, and then this is our utility function just to get the coordinates out. Okay, so next up, let's go and generate the actual map. Okay, so the first thing we're going to do is we're going to bring this map tile generation in as a system in Legion. So let's make a new tile map file as well. We're gonna have to take an actual tile map for this, and we are definitely gonna need a vector 2 for all the coordinates. And so we're gonna be doing a system, we need Legion. There we go, and let's see, am I missing anything? No. Okay, so this is where our components are. The tile map, and we're gonna have another one, map chords, which is gonna be a vector. It's gonna be a public vector of vector 2s. I think that's right, yeah. And we're gonna have to have a Godot tile map. This is gonna get a little bit confusing. There we go. And then we need a system. Systems. Let's call it systems. Okay. Well, I don't know if we're gonna end up with more than one. Generate tiles, and that returns a dynamic runnable, like all our other thread local systems. System builder, new generate tiles with query. There's a build thread local. Now I'm gonna open up the one I have in player. Okay, let's have a look. Let's see. Build thread local. Yeah, that's right. World and resources and query. There we go. All right. Okay, we don't need that. So then we need the actual query. And for our query, we're going to have two things. We're going to have a mutable, which means write tile map, so we can update it. And we're going to have read of map code, so we can see what we're going to set it to. And we are only going to do this if the map codes have changed. Is this all right? Well, that was very not right. Let's have a look then. Okay, so yeah, right. So we're closing. We're missing something. What am I missing? Oh, I'm missing. Okay, that one is there. That's right. That's right. Tile map and read. That's also right. I'm not seeing it. I am not seeing it. Okay. Okay, well, first of all, we need to do that part, that little ugly business. Unsafe implement send for tile map. So that's done. Okay, and then we need to fix this thing. We're missing that one. That one's fine. And that one's fine. Oh, this is so embarrassing. Closing the limit possibly meant for this. With query. Oh, right. Oh my god. Okay, alright. I'll apologize for that one. Anyway, let's pretend that didn't happen. So let's get a mutable reference to our tile map, and we need our map chords as well. And then we can call that with query dot mutably, pass in the world, and there we go. Okay, so now we're getting the map chords, but these aren't actually the tile chord. This is the chord of a block of tiles, okay? Because we would divide the world into 16. 16 by 16 tiles. So we can draw a bunch of tiles that are not on camera, and then we will move the camera, and then we draw all the tiles around this, and we can use those tiles to we draw the tiles, and we can use them for a mini map and all these kind of things. Okay, and we clear the map every time as well. So let's do that as well. Let's implement tile map. We need a new function that takes a Godot tile map. Feels weird calling that in a tile map. Call it GD tile map. And then we have another one for set cell. So we are just extending we're just wrapping the Godot tile map here. Probably need a mutable reference to self, and we need the chords that we're setting, which is a vector 2, and we need a cell ID, so which type it is. So that'll be an I64 set cell chords and cell ID, and then false on all these other things. That's gonna need to be unsafe, like so, and then we need another one to clear the map. There we go. Okay, apparently not. All right. Damn me. Okay, right. So now we can go through every tile map that we have. We're gonna have one tile map dot clear, and then let's see. So we want to go through all the coordinates now. Okay. So for x in map size. Yeah, this is what we're gonna do, and y, and now we're gonna create the actual. Okay, so now we're gonna create the actual coordinates for this, and we're gonna use what we did in ProcGen. And we're gonna do pack chords and get random choice. I don't like that name. I think we're gonna just call it random choice. There we go. There we are. Okay, so now we can use these things to find out which block it belongs to, and then using that we can find out where the actual tile will be, the cell. Let's make a new cell where the x value is x as floating point 32 plus, let's see, x will be 0 plus the map chords. No, that ain't right. Okay, so we need to do this. We need to do this for map chord. Chords x times map size. Whoops. Oh. Chords x times map size. There we go. Okay, tidy that up. So now we know exactly where in the block it is, where on the map it's going. And then we need to get the cell ID, and the cell ID is going to be the type of tile we have. So tile ID is equal to, now we need to get with the packer chords. That's not our tile ID, that's our seed. And then tile ID is equal to random choice. Pass in a slice where -1 is something you cannot walk on, and we pass in 4 of those, and then the seed. So 0 is where you can go, that's where there's a path, and -1 is where there's no path. And given all this, we can now do the actual setting of this tile map. Set cell, we need the cell chords and the tile ID. And that's something that ain't right. Okay, let's dereference this guy. And then see what else is giving me grief here. Not an iterator. Okay, no, of course not, because that is the iterator and is deref. Okay, there we go. Right, so we got all of this. And now that we have generate tiles, the next thing we're going to do is we're going to add this now to run in our game world on process. Because this is not doing anything with physics, so we run it here. Generate tiles. So we need to go and add this now. So use create tile map, generate tiles. We're also gonna need the map chords and the tile map. And now we're gonna have to go and rename all the tile map users here. So we change that to tile map. Okay, so let's go and find these. Tile map, there we have one. Godot. And there's one. And one. Okay, I think that's it. See if that works. Yeah. Now we just need to okay, so the next thing we're gonna do now is we're going to refactor all this. I'm going to commit all this first, but we're gonna refactor all this to use our new tile map wrapper for our tile map. So let's do that. Okay, so let's get rid of the things that we cannot use anymore. So we'll start with this map here. Okay, we cannot have this map there anymore because if you look down here, you can see that we're setting this map and it's based on our current tile map, but that doesn't work because this is changing. So we take that out, and once we have our tile map, we can now insert this into the world with world.insert. And what are we going to insert? The first thing we insert is tags, and they're empty. Next up is going to be our tile map, and then we're passing in the tile map that we've created up here. So we're passing in that guy, and let's put that on a new line, and then we need to pass in all our map chords. There's another back there, so it's looking a little bit messy, and then that's that. Tidy that up. Oh, no, we got an error. Okay, let's see then. Where do you belong? Okay, are we doing this again? Oh, right, there we are. Okay, my bad. There we go. Okay, now we're gonna have to break this down a little bit, because this is gonna be full of coordinates here. So we're gonna say vector2 new 0 0. Okay, so now we're gonna form a square. I use 9 coordinates to form a square. So we'll start at 1, 0, and then -1. And then we do the same thing for 1. And we do the same thing for -1. Whoops, not -11. Tidy that up. Okay, that's great. So now we have our map done with the map chords. So we should be able to, okay, so now that that's in there, we should now be able to refactor our usage of the pathfinding, which we're gonna do now, okay? Okay, so let's look at our pathfinding, which is move units. Okay, there we go. So we can no longer just say self.map here. Instead, we're going to use the I know we use sum obey. There, that's the one. That's the bit we're going to use here. And to get, well, hang on. We already have the tile map there, so that won't be necessary. Okay, ignore that. But this code here is what we're gonna need. So we'll take this and we'll say that the map is equal to this instead, and then we'll comment that out. So now we have a map, and then all right, and that, sorry, that returns an option, but that's not what we want. There we go, map, and let's see, 370 somewhere. Here's the problem. That needs to be a reference. Okay, and then that's a problem because that needs to be mutable. And that problem went away. Okay, now we just have a warning, which we'll go and fix now. Okay, and then we can take this block out as well. So now if we go and look at this in Godot, if I've done everything right, we should see a rather strange looking map with lots of holes in it. Okay, so let's do that. Okay, so there we go. All right, so we have a map, which now I can just walk right through it. These things, they are supposed to be walls, and these walls, they're hard-coded in Godot. So let's go and remove these walls for now and add them to our tile map. So let's get rid of the walls tile map for now and edit our tile set. Thought I deleted that. Okay, right, so that was me being stupid. Let's go and edit our tile map in again, and this time we don't delete it. We've got to add another tile, which is a wall. Zoom in on this a little bit. New single tile, and we want collision on that. There we go. Okay, so now we're gonna have to go and update our code. So if we save, quit, run this again. Okay, so there we go. We have no walls. You can just go anywhere. And you can go through these places where you shouldn't be able to go through. So what we're gonna do now is we're gonna go and fill those places with actual walls instead of empty tiles. So let's go back to our tile map where we generate this, and instead of having -1, we're gonna say 1 for wall. And when we do our actual pathfinding now, so this is clearly not a long-term solution because we cannot just have 2 tiles for this, either walls or walkable path. It'd be very boring. So let's see, where do we actually do our map? Down here, and we call get users by ID and pass in 0. Okay, so now everywhere we use 0, we are going to have the grass tile. Everywhere we use the grass tile, we are going to have that as walkable area, and then the rest is going to be a wall. Okay, so let's go back to Godot and check this out. Okay, so now they're walls. Will he do pathfinding? Yes, he will. So if I go there, he will find his way there. So now the camera is not moving, okay? Since we're gonna have 4 units, we'll have, we can't have the unit, the camera tracking the unit, so we're gonna have to do manual camera movement. I don't know if we're gonna do it by mouse or how we're gonna do it. But, all that said, now we actually have a player moving. And we're having a bad guy there. So what we're gonna do next? What am I gonna do next? Right, well, let's jump back into the code and have a think about that. Okay, so I had a quick think about what I'm gonna do next, and I think it would make logical sense to do the mini-map because that's effectively just gonna be the same as the regular tile map, and I might have a think about how I'm doing the pathfinding a little bit more as well. Thank you.